Hello and welcome to Unit 8, Part 1. My name is Mr. Bell, and today we're going to talk about even, odd, or neither functions. Sometimes when analyzing or reviewing different types of functions, patterns emerge. In this case, we're looking at three unique types of functions: even functions, odd functions, and then what's called neither. Let's talk about the even functions first. An even function is one that its graph is symmetrical about the y-axis. Now what that means is if I have some sort of graph here, and let's just say this part of the function goes this way, well, if it mirror images across the y-axis or symmetrical about the y-axis, then it is considered an even function. So what you're looking for is a line of symmetry that goes right down the y-axis, which is the vertical axis. And if it creates a mirror image on both sides, it is an even function. The next example is an odd function. Okay, the odd one's a little tricky. It's symmetrical about the origin, or another way to think of it is I'm going to try to draw a somewhat of a good drawing here. Its particular graph will be symmetrical about the origin. Okay, what that means is I'll kind of do it in green. It's both a reflection across the x-axis, so like a mirror image of your original part. Like if we were looking just at this portion of this function, notice how I reflected it, although it's a little crooked, I reflected it across the x-axis. Then, if you do another reflection across the y-axis, and it lands on the function. So I originally reflected across the x, and then I took this shape and mirror imaged it across the y-axis. If you make those two transformations, it is considered an odd function. Another way that it's described is symmetry about the origin. Any point here, if I go straight through the origin, it should be exact opposite spot across the function. And of course, a neither function would not fit either of the two criteria above. So this is an example of a neither function. It's not symmetrical about the y-axis. It does not produce a function that is symmetrical about the origin, so it is neither of the above. On this slide, it asks to determine if the function is even, odd, or neither, and we have four different functions here. So let's try to apply what we learned on the previous slide. On this top left example, if we look at our function, it is a mirror image across the y-axis. So it is symmetrical about the y-axis, making this an example of an even function based on the definition as before. Second example here, this particular function, it looks like if I reflected it across I'll do it in a different color. If I reflected it across the x-axis, it would look something like that, and then performed another reflection across the y-axis, it looks like it lands on my function. So this is an example of an odd function. The bottom left is not symmetrical about the y-axis, and it's not symmetrical about the origin like the odd function was, so this is an example of neither. And the bottom right one looks to be, definitely it's not even, because it's not symmetrical about the y-axis only. However, if I reflected it across the x-axis and then performed another reflection across the y-axis, looks like we have that example of symmetry about the origin, which makes this another odd function. All right, if you were given an equation and asked if it was even, odd, or neither, just remember you can use the graph function of your calculator, graph it, and look for these patterns that we've learned in this particular lesson. All right, thanks for watching and hope this helps.